Hey guys, welcome to my channel Euclid Mathematics and yet another video on ring theory. I'm going to solve here in my today's video the question from CSIR NET June 2019 which asks for 4.75 marks, that means multiple answer questions. So let's read our question. Let n belongs to z, then which of the following correct? Okay, so we have to figure it out which one of the option is correct between all our four options. So our question which solely depend on irreducible or reducible, okay, so which is depend on the reducible criteria or irreducible criteria. Okay, so now our first option, it says that the polynomial x cube plus nx plus 1 which is irreducible over z for every n. Second option, same polynomial is reducible over z if n belongs to curly bracket 0 minus 2. Again, third option, x cube plus nx plus 1 which is irreducible over z if n does not belongs to 0 minus 2. And fourth option, that similar polynomial is reducible over z if it has infinitely many n's. Okay, it is irreducible for infinitely many n's. Okay, before starting the solution of our example, we need to know what is meant by irreducible and reducible. Okay, in our simple language, if we say reducible means any polynomial which has a root, okay, which has a root in our given domain. Okay, so it is n belongs to z, it has to be root in a n belongs to z for that n. Okay, and irreducible means exact opposite direction of reducible, that means it do not have root over z. Okay, it do not have root in a z. So there are so many types of the irreducible criteria test that we can use to check the irreducible and reducible of our polynomial. Okay, so now let's solve our question. For solving our example, we use one result, a polynomial in a zx. Okay, that means integer polynomial is given which is irreducible over z, that means it do not have root in a z if and only it is a irreducible over q. That means here we have to check only over q. Okay, if the polynomial is irreducible over q, that means it is irreducible over zx. Okay, and if it is irreducible over zx, that means it is irreducible over q. Okay, so now we have to check it for whether our polynomial x cube plus nx plus 1 which is irreducible over q or not. Okay, so let's start our solution. We use one of the ratio test that to check whether our polynomial is irreducible or not. So here our polynomial which is x cube plus nx plus 1, so it first element which is having power 3, that means it is an odd degree polynomial. Okay, and we know that odd degree polynomial has at least one root in a real, but we are checking only in a q. Okay, only in a rational. Okay, so for checking in a rational we use the ratio test. Okay, so and it says that any polynomial we consider here which is irreducible over q or reducible over q if it hold the following property. Okay, so if it is irreducible over q, that means it has a root p by q if a naught by p and a n by q. Okay, so if a naught by p and a n by q, these two conditions hold, that means our polynomial is reducible over q for that certain value. Okay, so a naught means it is the first coefficient of x cube here, second coefficient here, and nth coefficient here. Okay, so a naught means here 1 and a n means here 1. Okay, so now let's check whether p divides a naught or q divides a n. Okay, so here we got it here 1 divided by p and 1 divided by q, because here a naught is 1 and a n it is also 1. Okay, so 1 divided by p and 1 divided by q, and we know that this is possible only when the value of a pq which is a plus and minus 1. Okay, because the number 1 which only divisible by two numbers, only plus 1 or minus 1 from any type of the numbers. Okay, so here I got the value for p and q which is equal to plus minus 1. Okay, so it represents that p and q gives the root of our f of x. Okay, so if we substitute that p and q plus minus 1, that means our f of x has a root for these values. Okay, now let's find out these roots. Okay, with the help of value of p and q. Okay, now substitute the value for x is 1 and minus 1 in our f of x. Okay, so when x is 1, then f of x which gives the value 1 cube plus n into 1 plus 1. Okay, so 1 cube it remain 1 plus 1 into n. Okay, so it remains n only and plus 1. Okay, so I got the value for f of x is equal to 2 plus n. Okay, and when f of x is having root, when 2 plus n which is equal to 0. Okay, when 2 plus n which is equal to 0, then only f of x is having root. So 2 plus n which is equal to 0, that means the f of x which is having root only for the value for n which is equal to minus 2 when we choose x as a 1. Okay, it is only for x which is equal to 1. So now left over here for x which is equal to minus 1. Okay, now substitute x is equal to minus 1 in our f of x. So f of x will remain f of x which is equal to, so x which is equal to minus 1, that means minus 1 cube plus minus 1 into n, because x is a minus 1 here. Okay, so plus 1. Okay, so we know that minus 1 cube it remain minus 1 here plus 1. Okay, and minus 1 into n is minus n, okay? So plus 1 minus 1 it get 0. So f of x which is equal to remain minus n, okay? So when it is possible, when f of x is having root, when we choose n which is equal to 0 only, okay? Because there we do not have other option for f of x having root, okay? So when we choose n which is equal to 0, then only f of x getting 0, okay? That means n is a 0, then f of x is having root, okay? That means we got the two value for f of x, okay? Where f of x is having root, okay? And that value is n is a minus 2 and n is a 0, okay? That means f of x is a reducible only when n is a minus 2 and n is a 0, okay? So that means f of x which is having root when n belongs to open interval minus 2 0, okay? That means f of x is reducible only for these two values, okay? Now let's check the option whether which one of the option is correct, okay? So here our option it is given, okay? Option A, it says that x cube plus nx plus 1 is reducible over z for every n, okay? It is irreducible. That means it do not have any root, but we got the value for n which is a 0 and a minus 2. That means it has the root for 0 and minus 2, okay? That means it is not possible. First option wrong, okay? Now next option it says that x cube plus nx plus 1 it is reducible over z if for the value for 0 and minus 2. Exactly, we got the same answer here in our solution. Now third option C, it says that f of x do not have root, okay? That means it is irreducible. That means it do not have root over z if n belongs to 0 minus 2, okay? N does not belong to 0 minus 2. And exactly which is the right option. Our f of x do not have root when n is a 0 and minus 2, okay? And now fourth option it says that x cube plus nx plus 1 is a reducible over z, okay? When it is reducible over z for infinitely many values of n, that means it has a root for infinitely many values of n, but it is not possible. We got the only two values 0 and minus 2 where f of x is having root, okay, over z. We checked it for over q, and you all need to remember the integer polynomial is irreducible over z, that means irreducible over q, okay? That is both are same, okay? So option D which is wrong, okay? So here it is correct option B and C, okay? Thank you everyone. Thank you for my lecture.